Finally, we are going to study example 28. In example 28, I am given a complex number z, which is 1 plus I, and I want to consider the geometrical effect on this point in the argon diagram when I multiply it by I, as well as when I multiply it by -1. So if I were to multiply it by I, from what I have already learned, it is going to be a rotation by 90 degrees anti-clockwise about the origin. Okay, and I can also investigate this using exponential form. I see that the angle is going to be increased by 90 degrees, which corresponds to anti-clockwise rotation, but the modulus remains the same, so it is a pure rotation. Now, what if I have now a multiplication by -1? Then I'm going to have this, bearing in mind that -1 can be expressed in exponential form as e to the power of pi I. Then the multiplication of these two numbers is going to be done this way. The modulus is going to be 1 times √2, which is still √2. As for the argument, I am going to add up these two, which means that I have now rotated it. Instead of 90 degrees here, it is now a rotation by pi. So this is a rotation by an angle of pi. And again, the modulus is unchanged, so it is a pure rotation of z. Again, it is in the same direction because it's still an addition. So it's anti-clockwise about the origin by an angle of pi. That was easy enough. Finally, we are going to consider a slightly more complex case in which I'm going to divide by the complex number √3 minus I. Well, once again, I'm going to write √3 minus I in exponential form because this will allow me to see the changes in the modulus and the argument more easily. Okay, so if I want to consider z divided by this, then if I were to write z in exponential form, I will get this. As for √3 minus I, it is this in exponential form. Then what is the transformation here? Well, I can see that the modulus has now changed, so it's no longer a pure rotation. There is some element of scaling involved. In fact, the new modulus is √2/2. The original modulus was √2. So my modulus is now reduced to half of the original. So it is a scaling by a factor of half, not just a scaling, but a scaling of the distance from the origin. Okay, which means modulus basically. And the other effect, of course, is a rotation, because my angle is now increased by pi/6. So this is a rotation of z anti-clockwise about the origin by an angle of pi/6. With that, we have concluded this section on the geometrical effect of arithmetic operations on complex numbers. In the next section, we will be studying loci in an argon diagram.